All right, so let's look at a few examples going over our recursive rules. So looking at number 1, it says match the given sequences to their corresponding rules. So looking at this, we have these 4 sequences right over here, okay? And we want to match them up to one of these rules on the right. So the first thing we need to notice is that I have 2 that are arithmetic over here, and then I have 2 that are geometric. So we can right then eliminate some of our options depending on the sequence. So we're going to start by going through and labeling which ones are arithmetic and which ones are geometric. So if I look at this one, oops, switch to the pen, there we go. To go from 8 to 4, I could say I'm minusing 4, but whenever I check from 4 to 2, that's not going to be the same rule. So from 8 to 2, or 8 to 4, I'm getting smaller, so I can say I'm multiplying by 1/2. From 4 to 2, I'm also multiplying by 1/2. And 2 to 1, I'm also multiplying by 1/2. Since we are multiplying by a number each time, we know that this is going to fit into our geometric family. Now let's check the next one. The next one, we have 8, 6, 4, and 2. These ones are getting smaller each time. To go from 8 to 6, I'm subtracting 2. And then we have to check the next one. This one, from 6 to 4, we're also subtracting 2. From 4 to 2, we're also subtracting 2. We are subtracting the same number each time, so we know this belongs to our arithmetic family. So we're just going to keep checking these to see which one. That way we can eliminate some of our options. From 8 to 10, 10 to 12, 12, and 12 to 14. We're adding, we're getting bigger. So from 8 to 10, we're adding 2. 10 to 12, we're adding 2. And 12 to 14, we're adding 2. Again, we're adding the same number each time, so this is also our arithmetic family. And then the last one, from 8 to 16, 16 to 32, 32 to 64. We're getting larger, and we're getting larger pretty quickly. From 8 to 16, we're multiplying by 2. 16 to 32, we're multiplying by 2. And 32 to 64, we're multiplying by 2. Now, looking at that, we're multiplying by the same number, so that one's also geometric. Now remember, these either fit into our linear or exponential families as well. All right, so now we can start with just the first one. We know this is going to be an arithmetic, so it has to either be this one, nope, not that one, or this one, okay? It has to be one of those two. So now we look at how they're changing. We know they're both starting at 8. Notice all of them start at 8, so we can't really use that to help us. But we can look at how they're changing. Well, this one is going up by 2. Well, if I look at this, my options are either subtracting 2 or adding 2. Well, this is adding 2 at the end, so we know A is going to go with the adding 2. All right, so that gets rid of that one for us. And we've done A. Now, looking at B, this one right here is geometric because we got the G right there. So we know it either has to be this one up here or that one. Our common ratio is a 2. So we look at which one of these are we multiplying by 2. Well, that's going to be this one down here. So that's going to be B. So that gets rid of A and B. The next one is also geometric. Well, the only other one that we have that's geometric is the first one. So that's going to be C. And if we look at this, the common ratio that we're using is 1/2. Well, if you look at this, 1/2 is our common ratio there. So see how everything kind of matches up? Well, not kind of, it does match up. And then letter D, this one is arithmetic. Well, we only have one more left over. And we see that our common difference was a -2. And if we look, we're subtracting 2 right there. So we know this last one has to be D. All right, I want you to go ahead and try number 2 on your own. Go through, identify if it's arithmetic or geometric, and then you can check your work with mine when you're finished. All right, so I hope you went through and checked all of these. Okay, we're just going to go through each one of these one by one. So if I look at the first one, to go from 9 to 6, we're subtracting 3, we're subtracting 3, and we're subtracting 3. Since we're subtracting the same number each time, we know that this has to be arithmetic. So I look at for which one has an A. So that's either going to be A or C. We're subtracting 3, so we want to make sure that the common difference that's being used is a -3. Well, the only one with a -3 is that one right there. So we know that this first one has to be C. On the next problem, this one we're adding 3, adding 3, adding 3. Since we're adding each time, we also know that it has to be arithmetic. Okay, so the only other one that's arithmetic is A. Well, that clears things up a little bit because we know the next two have to be geometric. So to go from 9 to 3, we're multiplying by 1/3. Remember, we don't say divide by 3. We're multiplying by 1/3. Okay, so since our common ratio is 1/3, we need to find the one with the 1/3, and that's going to be D. And then the last one, to go from 9 to 27, we're multiplying by 3, multiplying by 3, multiplying by 3. Okay, and since the last one is B, and our common ratio does say a 3, so we know that this one has to be B. All right, and then number 3, it says the height of a Ronald rocket can be modeled by the function h of t equals -16t squared plus 64t plus 1, where h of t is the rocket's height and t is the time after launch in seconds. What is the model rocket's height? What is the model rocket's height after 3 seconds? So for this one, we want to take this 3, okay, and we already over here said T is the time after the launch in seconds. So since I'm giving you the 3, which is T, we're going to substitute the 3 in for the T. So instead of h of t, I'm going to have h of 3 equals -16, 3 squared, plus 64 times 3, and then plus 1. So at this point, we are just going through and simplifying this expression. Okay, we plugged in everything, we plugged in our input, so now we need to find the output to go with it. Okay, so we have to start, this is really just an order of operations problem, so you have to start with your exponents. We always do those exponents first. So 3 squared is going to give me 9, plus 64 times 3. Oops, that's an ugly 3. Doesn't even look like a 3. 3 plus 1. There you go. And then now we're just going to keep simplifying. -16 times 9 gives us -144 plus 64 times 3 gives us 192 plus 1. So -144 plus 192 plus 1 is going to give us 49. Now my answer is not just 49. I cannot leave it at 49. I need to say the rocket's height. And remember, this is where our sentences have to talk about our input and our output. So I can say after 3 seconds, the height was 49 feet. All right. All right, if you have any questions about those, you can let me know. If not, you can move on to your assignment.